Good afternoon, ladies and gentlemen, or morning. Today we're going to talk about chemical changes and balancing chemical equations. To get started today, there are a bunch of definitions. So, our first is what is a chemical reaction? Chemical reaction is a change in which one or more substances are converted into new substances. Reactants are substances that react, they exist before the reaction takes place. Products, new substances that are produced after the reaction. Reactants yields products. So reactants are on the left and products are on the right. Conservation of mass says that mass is not created or destroyed, but instead conserved. Total mass of the products must always equal the mass of the reactant. That is why we have to make sure our chemical equations are balanced. A chemical equation is a saying that describes the chemical reaction by using formulas, symbols, and coefficients. Coefficients represent the number of units of each substance in a reaction. Mass is conserved because, or due to, coefficients can be used to balance the equation. The same number of atoms on each element must be on both sides of the equation. So looking here, a coefficient, which is like this 2 out front, tells how many of the entire molecule there are. Essentially, that's saying there are 2 molecules of H2O. For our next one, we have symbols. You guys should recognize most of these. So for this example, H and O are our 2 symbols. They tell which atoms are present in the molecule. H would be hydrogen, O would be oxygen. Finally, we have a subscript, which is the smaller number, and it tells how many of the preceding atoms there are. So in this example, it's saying in each molecule there are 2 hydrogens. Because there are 2 molecules, we would have to multiply 2 times 2 and get 4. We have a couple of examples just with counting molecules. So we're going to circle the subscript and draw a square or rectangle around each coefficient and answer the question. Our first example is O2. We're going to draw a circle around our subscript. There is no coefficient, so we have no square. What element is O2? You should know by now. O is oxygen. In our second example, we're going to circle our subscript. Again, no coefficient, so we don't need a square. How many of each atoms of each element are in the formula? So when I look behind C, there is an imaginary 1 there, so there is 1 carbon. When I look behind O, there are 2. In our last example, we have a subscript of 2 and a coefficient of 5. How many hydrogen atoms are there? We need to multiply 5 times 2 to get 10 atoms. In our next 3 examples, we're doing the same thing. Circling the subscripts, putting a square around our coefficient. Make sure you multiply there. So How many carbons are there? 4. How many hydrogens? 12. For our next example, we have 2NaSO4. So again, we're going to circle the subscripts, draw a square around the coefficient. We must multiply each one. So for Na, 2 times 2, we have 4. For S, we have 2 times 1, so that's 2. And for O, we have 2 times 4, it's 8. Very last example shows what to do when you have more than one of the same element listed. So I'm going to circle our subscript, put a square around our coefficient. We have one carbon here and another carbon there. So we must add them together. So we have 2 of these and 2 of these. So for carbon, we have 4. For hydrogen, we have 2 times 3, which is 6, plus the other hydrogen, which is 2. So we have 8 hydrogens. For our last example, we have O, which is 2 times 1 and 2 times 1, so we have 4 oxygens. Label the chemical equation using the words product, reactants, subscript, coefficient, and yields. So this first box is pointing to both magnesium and oxygen. They are on the left side, so that is reactants. This arrow is our next box. The arrow means yields. And our our next box is pointing to the one compound on the right side, which is magnesium oxide, also known as our single product. On the bottom, we have the number on the underneath, so that is called a subscript. And finally, we have the number in the front, which is called a coefficient. For the rest of this page, we are identifying reactants and products. So anything on the left is a reactant. Anything on the right is a product. And now we're going to start doing our practice problems. Remember, according to the law of conservation mass, there have to be just as many of one element on the right side as the left side and vice versa. So the way I balance, you draw a line where the arrow is, and then I'm going to list my elements. So I have S and O. On the other side, I'm going to list them in the same order, S and O. And go back and count how many there are on each side. 1 and 2. On the right side, I have 1 and 3. So the way you start is noting what's different. Obviously, there's 2 O's on one side and 3 O's on the other side. We have to make them the same number. The way to do that often is to figure out the lowest number that they can both go into. In this instance, it would be 6. So I want to end up with 6 down here. So what do I have to multiply by on this side? I'm going to multiply by 2. That changes how many sulfurs I have, as well as how many oxygens I have. So I go back to the left, and I'm going to make them equal by adding a coefficient. To make my oxygen 6, I'm going to add a 3 as a coefficient. To make my sulfurs 2, I'm going to add a 2 as a coefficient. 2, 3, 2. 2, 6, 2, 6. We are done. In our next example, we have N2 plus O2 yields N2O. So I have NO, NO. Then I count 2 and 2, 2 and 1. My O's are not the same, so I make them the same by using 2. That changes my nitrogens to 4 and my oxygens to 2. So on this side, I need to now change my nitrogens to 4 by adding a coefficient of 2. In our next example, we have sodium and iodine. So Na, I, Na, I. Okay. My iodines are not balanced, therefore I'm going to multiply my product by 2. That's going to change my sodium to 2 and my iodine to 2. Now I need my sodium to be 2 on my reactant side, so I'm going to add a coefficient of 2 there. Everything looks the same now. In our next example, we have aluminum and oxygen coming together to form aluminum oxide. My two elements are aluminum and oxygen on both sides. Go ahead and count. Okay. So I could start with my aluminum, but that only gets me aluminum. My oxygens are still unbalanced, and one's 2 and one's 3. So again, what's the lowest thing that they can both go into? 6. So over here, I'm going to multiply by 2. That's going to change my aluminums to 4, my oxygens to 6. Now I need my aluminums to be 4. And I'm going to place a 3 in front of my oxygens to make them 6. For example number 5, we have 3 elements, carbon, hydrogen, and oxygen. Go ahead and count. Remember, for our oxygens, we're adding this and this. Okay. I can start with my hydrogens. Over here, I need to add a 2 so that my hydrogen is 4. So those match. Now, that changes my oxygen to 4. That's the only thing unbalanced. So I go back to my reactant side, and I can indeed make oxygen 4 by multiplying by 2 as a coefficient. And everything is balanced. Our last example, we have another combustion. So we have C, H, and O. I'm going to go ahead and count those. So again, I could start with my carbons at least. So that's 2. My hydrogens, that's going to make my carbon 2. My hydrogen 6, so those match up. My oxygen, this is 4, and this is 3, so that's 7. Can I make my O2 7? I cannot, because this always has to be a whole number. So if I can't make it 7, the next lowest thing I can make it is to double it and make it 14. So I'm going to double all of these numbers that I already have in order to end with my oxygen being 14. So my 2 is going to become a 4. My 3 is going to become a 6. Now I'm going to recalculate. So I have 4 carbons now, 12 hydrogens, and 14 oxygens. Back on the left, I need to make them all equal that. So I start with putting a 2 in front of my C2H6. That evens out my carbon and hydrogen. In order to make my oxygen 14, I need a coefficient of a 7 in front of my O. That is the last example we have to do. Please let me know if you have any questions on your homework, and I hope I can help you. Have a good day.